Let's see the next topic, free space management. Okay, so free space management maintains the list of free blocks in the disk. Okay, so the disk space is limited, so we need to reuse the space which are deleted. Okay, and that is used by previous files. Okay, so when the previous files are deleted, we reuse those particular blocks and allocate those free blocks to the new files that are created. Okay, so to keep track of this particular free disk space, the system maintains a free space list. Okay, so free space list records all free disk blocks. To create a file, we need to search the free space list for a required amount of space and allocate that particular space to a new file. Okay, so the space is then removed from the free space list when it is deleted. Sorry, when allocate after allocation of it allocation, then those blocks which are given to a new file. Okay, these free blocks will be removed from the free space list. Okay, so when a file is deleted, the disk space is free. That means the blocks that are used by the free deleted file, okay, will be free, and those blocks will be added to the disk space, that is free space list. Okay, so in a free space management, we have several methods to manage this particular free space. First one, a bit vector. Second one, linked list. Third one, grouping. Fourth one, counting. Okay, so let's see bit vector. This part, each block is represented by one bit. In a bit vector, each block is represented by one bit, where one represents the free block, 0 represents the allocated block. Okay, so consider there are uh, free blocks. Okay, so these are the free blocks: 2, 3, 4, 5, 8, 9, 10, 11, 12, 13, 17, 18, 25, 26, 27 are free blocks. And remember, in a computer the number starts from 0. Okay, so there will be a bitmap or bit vector. There is a bitmap or bit vector. So this is 0th block, this is first block, this is second block. Okay, so here we can see represent the 2, 3, 4, 5. There are contiguous 4 blocks are there. So there will be a contiguous 4 ones will be there. 4 ones. These 4 are actually free. Okay, followed by 0, 0 is used, then followed by 1, 2, 3, 4, 5, 6. These 6 blocks are free, followed by 3 blocks are taken. Okay, so the advantage of this particular bit vector is it is relatively simple and efficient, simple for finding the first free blocks. Okay, so it is easy to find it how many consecutive free blocks are there. But the problem with this particular bit vector is these particular bitmaps or bit vectors will be stored in the main memory. Will be stored in the main memory. This is suitable for smaller disks. These particular bitmaps are suitable for smaller disks, but they are not suitable for larger disks. That okay. So when it comes to a hard disk size that is increased, then this size of the bit vector is also increased. How? Let's see. If you take a hard disk size of 1 TB, if you take a hard disk size of 1 TB and a block size of 4 KB, block size of 4 KB, this is to the power of 40 and this is to the power of 12. The approximate size of the bitmap will be 256 MB. The approximate size of bitmap will be 256 MB. See, to the power of 40 by to the power of 12, you get to the power of 28. So to the power of 8 into to the power of 20. So this will be 256 MB. So this particular 256 MB of bitmap you should store in the main memory. So it is not efficient. And if you keep increase this particular size of the disk, the bitmap size is also increased. Okay, so that's why it is not suitable for larger disk, which is suitable for smaller disk, size of smaller disk. When the size is increased, the bit vector or bitmap size will also be increased. So next one will be linked list. Okay, so the linked list maintains the linked list. The first all the free blocks are pointed by one other. Okay, so what will happen in the linked list? In a linked list, all the free disk blocks are linked together. Okay, so there is a pointer that is pointing to the first free block. See here, the pointer is 2. The first free space list head which is pointing to the first free block, that is 2. Okay, then 2 will point to 3, 3 will point to 4, 4 will point to 5, and 6 and 7 are taken by some particular file. So 5 is pointing to 8, 9, 10, 11, 12, 13, and 13 is pointing to 17. Okay, so each block, free block, will pointing to next free block. Okay, so the system would keep a pointer to block 2, the first free block, and it will keep on adding the pointers. But this particular scheme is not efficient. This scheme is not efficient because to traverse a list, we must read each block. We must read each block, and which requires uh, either input time or output time. So it is a substantial input output time. Okay, the time taken to find a free block and allocate the free blocks will be high in linked list. So in order to avoid this one, what we will do, we will take one more concept called grouping. Okay, which is similar to indexing. What we will do, it stores the addresses of n free blocks in the first free block. Okay, so if there is a block will be there, this particular block consisting of the first, okay, suppose that there are n blocks are there. Okay, there are n blocks are there. Within these n blocks, the n minus 1 blocks, the first n minus 1 blocks are free block addresses, then followed by next last one, nth block. Okay, the last block will point to the next free space index blocks, next free space index blocks. So we are grouping some free blocks into one particular place, so that it will be easy to allocate and easy to uh, 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 give the blocks to a file, assign the blocks to file. Okay, so the n minus 1 of these blocks are free blocks, and the last block contains the address of another n free blocks. Okay, so addresses of large number of free blocks can be found quickly than linked list method. Okay, so next one is counting. Counting will be used when we are using a contiguous allocation method. Okay, the files are allocated contiguously, this counting will be used because this when you use the contiguous allocation. Okay, we will keep now look at here, in counting, here we keep the addresses of the first free block and address of the first free block and the number n free contiguous blocks. Okay, so that consisting of the first block address, first free block address, and followed by how many contiguous free blocks are there, how many contiguous free blocks are there. So here, if you see this one, it will be first 2. Okay, the first free block will be 2, and 1, 2, 3, 4 will be there, then contiguous 4 contiguous blocks, then followed by 8. We count 8, 9, 10, 11, 12, 13. Next we'll take a count. So yeah, 6 blocks are free, 6 blocks are free. Okay, so each entity in the free space list, then sorry, each entity in the free space list then consisting of a disk address and the count value. Okay, then the overall the disk entries will be very small as compared to other free space management methods. Okay, let's see next topic, directory implementation. We can implement two ways. First one is linked list, second one is hash table. First one is linked list and second one is hash table. Let's see linked list. Okay, so in a linked list, it maintains a list of file names with a pointers to the data blocks. Okay, pointers to the data blocks. So it is time consuming. The linked list is time consuming because the search it is used is linear search. The search operation that is used by linear list method is linear list method is linear search. That is, it will search one item after other, one block after other, one after other, one after other. Okay, so what will happen when you wanted to create a file? When you wanted to create a file, we will apply linear search on the directory. Okay, and after linear search, we find that whether the given name, the given name is present in the file or not. Okay, already existing files are. If the file name is not present in the not given for any existing file, then the new entry, we will add a new entry into the directory. But where we'll adding at the end of the directory. Okay, a new entry at the end of the directory will be added. Okay, see, and one more thing, in order to delete a file, again we will apply linear search on the directory with the file name that is given, that is a file name f1.c is given. So we'll search this particular f1.c using linear search method. If the file is found, then we'll delete the file, and whatever the data blocks that are assigned to the file will be released. Okay, will be released, and these released blocks will be assigned to free space manager. Okay, so to reuse the directory entry, either we mark the entry as unused, or we can attach it to the list of free directory entries. Okay, so the disadvantage of this one is it uses the linear search, which will take more time when it comes to searching, because linear search is very slow. Okay, so next method, that directory implementation method, is hash table or hash function. Okay, hash table takes a value from the file name. Okay, it will take value from the file name and computes and returns the pointer to the file name in the linear list. Okay, it returns the pointer to the linear list. Okay, so advantage of this particular hash table is insertion and deletion are very easy to implement. Okay, so the major difficulty with hash tables are generally they are in fixed size. They are in fixed size and depends upon the hash function. Depends upon the hash function. Okay, so let's see an example. Assume that we make a linear probing hash table with holds 64 entries, which holds 64 entries. So these 64 entries, when you give a file name to this particular hash function, the hash function converts the file names to 0 to 63. Converts the file names to 0 to 63. Suppose if you try to create a 60, that means how many maximum number of files that we can create? 64 files. Okay, so if we create one more file, if we try to create one more file, that is 65th file. Okay, so we need to extend this particular hash function. We need to extend this particular hash function range to 128 entries. We need to extend this to 128 entries. So the new hash function will map the file names to 0 to 127. Okay, and it must recognize the existing directory entries to reflect their new hash values. Okay, so and after this particular thing, if you want to create some 129th file, again the new hash function will be extended to 256 entries. Okay, so this is a bit problem when it comes to hash table, but the problem with linear list that will be overcome with hash value. So hash table will have a hash function. This particular hash function will convert your file names into integers, file names to integers. Okay, so depends upon the hash function, the number of file names will be given. Okay, entries will be in the table.